Jai Shri Manaran kids. Today's class today we'll discuss about the 23rd January Shift 1 Physics JEE Mains 2026. Physics paper easy and formula based like what we had earlier, like almost all the PYQs, the same pattern what physics we are expecting, formula based and easy. Chemistry moderate and tricky. Now only in this year now we are seeing some 4, 5, 6 questions where they're asking some conditions and you have to analyze here. Because of that, what happened? This part has become tricky. Like that, not total paper. Around we can estimate 5, 6 questions. Not tough, the tricky. That's why what happened. Rather than becoming easy, there we are classifying it as moderator. And maths, as usual, past 3 years, difficult and lengthy calculations. The idea should flash, and this one, like that, the lengthy calculations, there are 9 questions are there, which will easily kill the time. Because of this, we are putting the difficulty. Overall paper, we can say like a moderately difficult. So then we'll start with the marks. For 94 marks, we'll get the 92 percentile. And for 101 total marks, 101, you'll end up with somewhere 94 percentile. Then 1 and 12 marks, 95 percentile. 123 marks, 96 percentile. What do you mean by 123 marks? In each subject, 10 questions also, if you solve, you land somewhere here. And 149 marks is about the 98 percentile. The threshold, or what you can call 150. Exactly 150. So you have to solve 12 questions from each subject. Then you are on safer side. 98 percentile. I think this is almost on and average for all the papers. No, there's a one benchmark you can keep it 150 98 percentile. And to have the 98 percentile, 12 questions from each subject. Altogether 36 questions if you can solve. No, you land, you are going to be on safer side. 12, 12, 36 into 4. So easily it will come to around 144. So this was the basic thing, 150 marks, no? So those who are writing the 24, 28 shifts, please take note of this one. Your target is something 12 questions from each subject. Altogether, 36 questions if you can solve in 3 hours, you'll land on safer side. For this, you plan properly. Suppose a maths difficult and lengthy. What to do for this to improve the score? When you say this is easy, what happened from here save time, from here save time. Add for this. Definitely, your score you can improve in the difficult paper. Agree this? This is applicable for all these things. Difficult paper, if you solve 7, 8, or 10 questions, what happen? You will get very good percentile. This is very important. Easy paper. Now you have to solve 15 to 16. So these are the few things which you have to plan properly here for the exam, that one. Difficult paper, spending more time, easy paper, saving time. Next further, 164 marks, 99 percentile. There's also, we can put 160 to 170 marks. This was the typical, the boundary of 99 percentile. 98 percentile, 140 to 150. So within this, you have to plan it. Okay, and we have this all I'm talking about the open category reservations. Once the total papers get over, no, then we'll go for the reservations. Okay, this is about the overall today's paper. We can call it as like a lengthy paper rather than difficult. No, better say lengthy paper. Paper is lengthier. Okay, now we'll go for the typical or physics weightage one. What do you mean by physics weightage? We'll divide the physics into units: mechanics, LCT maximum, modern physics, optics, thermal physics, waves and sound, experimental physics. In this particular paper, mechanics 10 questions came. LCT maximum 7, less compared to previous one. It was less, no. Then modern physics, 2 questions only. Yeah. What are the 2 questions? One photoelectric effect, one atomic physics. One atomic physics, one matter waves. Fine. Next, optics. We're having 3. Thermal physics 1. Waves and sound, no question in this. Experimental physics 2. One on 1 year caliper, one on the errors. Like this is what the weightage. Okay, these things is what the bulk, no, mechanics, LCT maximum. They will cover in year also. Or you can go for like this. They will help you a lot in exams. Sir. Next, we'll go for the physics type of questions. What do you mean by type of questions? Physics, the type of questions are numerical based as usual 5, which are again formula. Through the formula, you can manage these 5 questions. In objective type also, there are 11 questions are there. Together, these two are the 16. Together, these two are the 16. Then objective derivations type, 9 are there. Little bit more here. Usually it used to be 5, 4. This time 9 are there. What is the advantage of this formula? Means the paper, what happen, scoring will be more if this number is more. You should be conceptually strong if you have this derivation type question comes. And here I think objective type, no conceptual, sorry, assertion, reason, and match the following. Okay, there are no questions from here. Sorry for disturbance. Now these are the things today's paper. This is the thing which will determine your rank. For this, what you should do? Formulas, concepts. The more formulas, concepts you revise, the more safer side for you in exam. What are all about exam is only substitution type, the formulas. What all there's a methodology what you should plan for the coming shifts. Okay, let me enter into the. Okay, some many students they ask like, sir, like, what is the 24th and 28th last 4 papers are left over, sir? Like, what is the thing? You can do one thing, collect all papers, those who are writing now 24 tomorrow, no 6 papers you are having. Check what is not asked. Definitely will come. You check the polarization, till now not came. Then Zener diode not there. Like that, so many concepts are there which they are not stressed. Definitely once you must revise them, they'll help you a lot. Especially those who are on 28, you will be having 8 papers with you. What has not come, they should be given priority. What is being asked, okay, fine, good, but what has not yet asked till now, better to revise safer side so that it'll be easy, no, for you what you prepared and came. So all these strategies you must apply here. Okay, fine. We will go for the paper discussion. I will take out this screen. We will send this person. Only you can hear me that one. We'll say goodbye to this person. Okay, now we'll start with the first one. The first question is based on the simple pendulum. Simple pendulum oscillations. I'll start with this one. Yeah. The first question is based on the oscillations. Oscillations. Let me adjust the name. No. A simple pendulum of length 30 centimeter makes 20 oscillations. makes 20 oscillations in 10 seconds. It's on a certain planet. Another pendulum makes 40 oscillations in 10 seconds on same planet. Find the length of the second pendulum. Time period T1 equal to 2 pi root of L1 by G. T2 equal to 2 pi root of L2 by G. T1 by T2 equal to L1 by L2. What do you mean by 20 oscillations in 10 seconds? Time period will get it. In 1 second, how many oscillations? So this will become 20 by 10. This will be 40 by 10. Length L is 30 centimeter. We have to get L2. 10, 10 get cancels. This 10 and this 10 will cancel out. So what is the basic idea? 20 oscillations in 10 seconds. Time period will be 20 by 10. 40 oscillations in 10 seconds. Time period will be 4. So this 10, 10 cancels out. 0, 0 cancels out. 2 by 4, 1 by 2. 1 by 2 is equal to 30 L2. 1 by 4 equal to 30 L2. 30 centimeter. L2 equal to 120 centimeter, 1.2 meter. 30 centimeter, 20 oscillations in 10 seconds. 20 by 10, 40 oscillations in 10. We are having this 1.2 meter, 120 centimeter. Calculations correct, no? 10 by 20. Okay, fine. 10 seconds, time taken for 20. 10 seconds is the time taken for 20. Oh, reverse I took it. Okay, fine. This is let me redo it. Reverse time taken for 20 oscillations, time taken is 10. So 10 by 20. For time taken for 10 seconds, it will take the 40. So this will become 30 L2. So this will become 2 equal to 30 L2. So 4 equal to 30 L2. L2 equal to 7.5 centimeter. Next question will take the when there is no dielectric, then the value of capacitance is C. Now some dielectrics inserted in this capacitor as shown in the diagram. If capacitance become NC by 3, then find the N to the nearest integer. Okay, these are like a dielectric slab one. Here we will choose like this. Capacitance, these two are parallel. That effective will be in series with this. We'll draw the diagram. Okay. We'll give number like this: C1, C2. Let this be C3. Here K will be 5. Here 3. Here it will be 2. C12 will calculate. C12 will be, these two are C1 plus C2. C1 will be how much? C1 will be epsilon naught KF5 epsilon naught A by 2 D by 2. C2 will be 3 epsilon naught A by 2 D by 2. This will become 8 epsilon naught A by D. This is the value of C12. What is C12? Effective of these two. Okay, what is C3? C3 will be 2 F naught A D by 2 will become 4 F naught A by D. Now the effective of these two are in parallel, will adding up. This C12 will be in series with this one. Now the effective capacitance will be 1 by C equal to 1 by C3 . C is equal to 8 epsilon naught A by 3D. This 8 will come. These are based on capacitors with dielectrics. We'll take the next one. This is based on matter waves. Question is, find the de Broglie wavelength of oxygen molecule at 27 degrees Celsius. Molar mass of oxygen molecule is 32. Now something problem based on de Broglie. What is the average? What is the kinetic energy? Will be 3 by 2 kT. Boltzmann constant not given. K value will be 1.38 into 10 to the power of minus 23. Temperature given 27 degrees Celsius, convert into Kelvin. We'll get average. Then lambda equal to H by mv or H by 2m. Okay, this one. Again, what is the problem? H value will be 6.6 into 10 to the power of minus 34. 2 mass needed. Molecular mass he has given 32 gram, gram molecule, 10 to the power of minus 3 by Avogadro number 6. Into this value 3 by 2 1.38 into 10 to the power of minus 23 into 300. Enjoy the calculations. Everything is what? We'll get the lambda. The concept is simple. It's all about the calculations. Now slowly the JEE Mains is focusing on the how good you manage the calculations. Please try to understand 10 to power of 23. Okay, we'll get this one nearest. 10 to power of minus 10, we'll get like this. Fourth one, based on electrostatics. There are 2 point charges, one at vertex and other at phase center as shown on the cube. Find the electric flux through the cube. One at vertex, here, one will indicate the charges. One charge is here. The other one, phase center. How much of flux through the cube? Really, it's like a geometrically you have to think it. Now, this particular cube, due to this, it is at corner. So what you should do, assume another 7 cubes so that this will become center. Then how much of flux will be through the cube? Due to this will be 1 by 8. Now you have to assume another 7 cubes like this. Okay, fine. Like that 7 cubes will come. Here 1. Total 7, 8 cubes, and this 2 cubes become center of it. I think I can't draw the diagram. 3-dimensional it is not possible. Roughly I can show like this. This is a 2 cube. This is a cube 1. Like that I assume 2, 3, 4. Another on it. This will become center. How much of flux through this cube? What was our question? Our question was asked for this. How much of flux through this phase? This particular cube. Then this is there at the body center. For body center, what we should do? This is exactly the body center. Sorry, face center. It is placed here. So how much of flux will be? It will be equal to Q by 2 epsilon naught. You have to, what you should do is like you should assume another cube like this and make the Q center of these two. So half of the flux will link this cube here. So the total flux linking will be now total flux through cube will be 2Q by 8 epsilon naught Q by 2 epsilon naught. So will become 3Q by 4 epsilon naught. Based on electrostatics Gauss law. This is based on the electromagnetic induction motion EMF. A rod of mass m this is a rod of mass m. It will be falling in a magnetic field. Everywhere here we are placing a magnetic field. We have switched on a magnetic field. Uniform magnetic field. Length of the rod is L. falling through a distance x. What is x? X is this one. This is the magnetic field. It will accelerate. Mg will act because g is given. Sir, how you can say g? Because gravity is given, no? So what is the velocity it will acquire? V equal to root of 2gx. It is released from rest. Then EMF indeed is equal to BLV. Motional EMF concept. Huh? Next one. Based on alternating current. Find the capacitance C for the given circuit. He has given the AC source and its angular frequency is given. Inductance, resistance value given. And here we have to calculate the capacitance of this. And there's no other information. Something is telling I naught sine omega t. What does it mean? The circuit is at resonance. Sir, how you can say? At resonance, the phase angle of the circuit will be zero. The applied voltage and the applied current will be in phase. This is a concept. I'll write it here. At resonance. Sir, how you can say resonance? Because sine omega t, sine omega t. At resonance, phase angle of circuit will be zero. At resonance, voltage and current are in phase. Okay, fine now. So definitely, what is omega equal to 1 by root of LC? Omega value 100, L value 20 into C. Squaring this, 10 to power of 4 equal to 1 by 20 C. C equal to 1 by 20 into 10 to power of 4. 5 microfarad. This is capacitance. At resonance we are discussing. This is a rod. I think the diagram has become very smaller. I think visible now. Okay, fine. This is a rod. There's a frame. And it's rotating about this axis. What is the axis of rotation? This axis of rotation. It's asking find the moment of inertia of each rod of the system. What is the mass of each rod? M by 4, M by 4, M by 4, M by 4. All are cylindrical rods having radius of cross section R. They're not thin rods. And length also given. A little bit some very good question. Now first, moment of inertia of this rod will be moment of inertia. What should be the formula for the cylindrical rod of length L? Mr square by 4 plus ml square by 12. Hope can you remember the moment of inertia concept for what how you have to recollect for a cylindrical rod about an axis passing through center and perpendicular to its length. What is the formula basically? Mr square by 4 plus ml square by 12. For each individual rod first we'll calculate. For this rod, How much moment of inertia about this axis? L by 12, L by 12, and this radius is R. Then what is the moment of inertia? I'll call I1. Will become I1 equal to how much? I1 equal to, here I am writing, mr square by 4. Mass is m by 4, no? 4 plus m by 4 L square by 12. There's a moment of inertia. Like that, two rods are there, two types of this. Then moment of inertia of the vertical part, will write it. There's a vertical part. Vertical part will be mr square by, what is the axis? Axis will come like this. L by 2. Radius will be r. Moment of inertia, this will become I2 is equal to m by 4 r square by 2 plus m by 4 L by 2 whole square. What is the total moment of inertia? Like this, what we are having? We are having this one rod, this one rod, and this one rod will become 2 times of it. Okay, similarly, this one and this one will be 2 times of this. So here nearby diagram, I'll write it. This will be I1, this will be I1, I2, and this will be I2. So total moment of inertia of the system will be I dash equal to 2I1 to I2. You have to manage the calculation. This is based on the rotational motion. This based on the work energy power A and B identical point masses. A is released as shown in the diagram. This is A at an angle 60 degree from the vertical. Find R. We have to calculate the radius of this circular track. If B is able to reach point C, point C after collision. Circular motion only. The diagram may be a little bit confusion. It has to complete the vertical circle. It has to complete the vertical circle. So what about two particles where they are? This is one particle. This other particle. Let me indicate this one particle. This other particle. Okay, fine. Now this A will come and collide with the B, and the velocity imparted to the B such that it should complete the vertical circular path. Directly, we'll do one thing, rough diagram. A, this is B. just before collision. This is A, this is B. A is having velocity u, and after collision A will come to rest. B will acquire velocity of A, and it should move in a circular path. Everyone able to understand what is a, so B should come here, should complete the circular path. If point P is here also, no problem, it has to complete the vertical circle. This will come to rest. This angle theta. So how much decrease in potential G of this will be at rest. This will be at rest. Before collision, B is at rest. Now the decrease in potential G of this. Decrease in potential G of the A. How much it is? There will be decrease in potential G of A. It will descend like this, no? After collision, the B will move in a circular path like this. And A will be at rest. Now the decrease in potential, you will write it. So I think it will descend some height h here. This h will calculate mgh is equal to mgl 1 minus cos theta, which is equal to mu square by 2. So u equal to root of 2gl 1 minus cos theta. 2gl 1 minus 1 by 2 root gl. After collision, so what should be the u equal to? Find r if the u equal to root of 5gl. This is equal to root 5r. This is r. This radius is r. Root 5gr. Root gl is equal to root of 5gr. L is equal to 5r. R equal to L by 5. 1 by 5. Maybe the diagram so adjusted r equal to L by 5. The diagram is little bit adjusted. Rough diagram I am drawing. So in fact both need not be having same length. Here for our convenient. B is not suspended. B is some of you are getting confusion. B is just a particle. Okay, no, this is not a string. Oh, you understood, no? Next one. Among the given options, choose the correct energy of the transition. I think you have to write all the possible things. Equal to En equal to minus 13.6 Eltonode Z square by N square. For hydrogen 2 to 1, it should be how much? 10.2 electron volt. Agreed? This will be beryllium, this one, E1. I think all are 2 to 1. First, we'll do one thing for hydrogen. For hydrogen, what is the energy? E1 is minus 13.6 electron volt. E2 is minus 3.4 electron volt. The difference of this should be 10.2, so not possible. Next, we'll go for lithium double plus. E1 will be helium, no? Lithium double plus will be 122, z equal to 3 will come. Z equal to helium plus lithium double plus z equal to 3. Z equal to, here z equal to 3. This is z equal to 1. Then minus 13.6 electron volt, 9 square by 1. 81 into. Then E2 value will be minus 13.6 electron volt, 9 square. This will be 4. The difference of this, we have to check it. Next, for helium plus. Helium plus z equal to 2. E1 equal to minus 13.6 electron volt, 2 square 1, minus 13.6 electron volt, 2 square, 2 square. The difference of this, we have to check it. 54.4 minus 13.6 will end up this one. Beryllium, again, z equal to 4. Beryllium triple plus. E1 will be minus 13.6 electron volt, 4 square by 1 square. E2 equal to 4 square. Again, check the difference. It will not match this. Based on the atoms. Okay, this based on the ray optics. Find the angle A of the second prism so that light ray suffers dispersion without deviation. So don't get confused. It's telling dispersion without deviation. There are two prisms are there. One mu1, other mu2. So we'll choose the red color ray of light. Like this will come. Next, we'll go for the violet. There's a violet. Next, there's a yellow. No deviation. Huh? These two are parallel. This yellow and this yellow will be parallel. This is what happening here. So there's a dispersion, no deviation. So the deviation Net deviation should be 0. Delta 1 minus delta 2. They should be 0. Mu1 minus 1 A1, mu2 minus 1 A2. 1.72. Okay, do calculation very easily. 11th one. There are two spring block systems. There are two spring block systems as shown. They are in equilibrium if m1 by m2 is equal to alpha, k1 by beta, k1 by k2 equal to beta, then the ratio of energies of the spring. What do you mean by ratio of energies? At elongation, here we will balance the weight. M1G will be balanced by K1X1. M2G, K2X2 is asking to get the ratio of these two. U1 by U2 equal to K1 X1 square by 2 K2 X2 square by 2. At equilibrium, K1 X1 equal to M1G. K2 X2 equal to M2G. K1 by K2 X1 by X2 whole square. K1 by K2. X1 by X2 will be M1 by K1. M2 by K2 whole square. This will become M1 by M2 whole square. K2 by K1. M1 by M2 will be alpha square by beta. And this based on the work, power, energy, springs concept. Rotational motion, angular momentum concept. Masses m and 2m are connected by a massless rod of length d. If angular momentum about axis passing through center of mass and perpendicular to length is L, the angular speed of the system. L is the length, so this let it be R1, R2. This length let it be R1 and R2. Then we should know MR1 is equal to 2MR2. R1 plus R2 is equal to L. And this is equal to R1 equal to 2R2. Moment of inertia M R1 square to M L square by 3. Moment of inertia. Then angular momentum. Oh, length of the rod is Length of the rod is D. Some symbol. We'll change the symbols. All this. This is the usually length of the rod will go for L, no? So this is D, D, D. Angular momentum is equal to I into omega. L 2m d square by 3 into omega. 3L by 2m d square. We'll take the next one. 13th one. The problem based on Young's double slit experiment with two different setup fringe width are equal. Setup fringe width are equal. If the ratio of slit separation is 2, wavelength ratio is 1 by 2. Find the ratio of screen distance in both the setup. And in order to draw the diagram, it is based on YDAC wave optics. What is the concept here? It's telling that fringe width are equal. Fringe width formula lambda 1 capital D1 by small d1 equal to lambda 2 d2 by d2. This wavelength lambda 1 lambda 2 slit separation 2 d1 by d2. Okay, fine. Can you work out simple calculation? We'll take the next one. A rod of mass m and length L is released from the portion as shown with upper end hinged in uniform horizontal magnetic field B. Find maximum EMF induced in the rod. Okay, fine. Where the EMF induced will be maximum? When the rod becomes vertical. When the rod becomes vertical, then the EMF induced will be maximum. Rotational EMF is what? You have to go for it. What is the rotational EMF? E equal to B omega L square by 2. How to bring this angular velocity? The rod is hinged here. Moment of inertia. So decrease in potential energy mgl minus L cos 60 degree. This should be equal to I moment of inertia P. IP omega square by 2. mgl by 2 moment of inertia ml square by 3 omega square by 2. Omega equal to 3g by L. This value substitute here. B root of 3gl L square by 2. Okay, now this is the basic formula. Half I omega square 1 half L cos 60 ml square by 3. 1 by 2 is also there, no? This will become B L square by 4 3gl. 3G should be there. Okay, fine. Find the maximum EMF induced. The EMF induced rod will be maximum when it's in vertical portion. Something we are having equation like this. L square if you send inside L to power 4 3GL cube. Okay, fine. It will come like this only. And this will become 4. 16 will come. 3GL cube by 16. B will be there. Or BL correction 16. And this again motional EMF, electromagnetic induction. Question number 15. A circular ring of two wires AC and BC are joined as shown in figure. If all wires have resistance lambda ohm, find the equivalent resistance across A and B. This will have this part will have one resistance. Wire AC. This is the one part. This is the next part. And these are the wires. Across AB is asking. So we will draw the equivalent circuit. This is a point A, B. AB. And again one more. So what are the why you are drawing all these things? This is one, this other one. Through colors I'll draw it, it'll be easy for you. This other one and this other one. No, only defining the resistance. What is the we'll call this as P here. R this value will be resistance per unit length. Okay, this small symbols will use R1, this R1, this R2. Let this be R3, R3. What is R1? R1 will be lambda into 3 pi by 2. R3 will be lambda into R. R2 will be lambda into now these two are all parallel. 1 by RAB equal to 1 by R1, 1 by R2 plus 1 by 2R3. Solving this will get the required answer. Now this is based on current LCT. Now can you do calculation? We'll take the next one. Two balls made up of same metal collide perfectly inelastically. Collisions in one dimension. Energy lost in the collision is completely utilized for rising temperature of each ball. Find the rising temperature of the ball. I think collision mixed with the calorimetric concept. They'll collide here now. There's a ball A. There's a ball B. They'll come and collide. Just before collision and this after collision. We'll have two set of diagrams. A, B, A, B. This will be 10 meter per second. 15 kg, 25 kg. The same. They'll be moving with the same speed. Specific heat of both the balls is same. So he's asking to get the new temperature. They'll come to rest. No. Will they come to rest after collision? We look at the momentum. Initial momentum. 13 to 25. 750 for the ball B. 750 for the ball B. Yeah? Then what about this? 150 for the ball A. So after collision, both will be moving with a common velocity towards left. We'll calculate that common velocity. This will become 250, 25 into 30 minus 15 into 10 is equal to 25 plus 15 into V. 750 minus 150 is equal to 40B. 75 minus 15, 50 is equal to 4B. B is equal to 25 by 2 meter per second. Now the decrease in kinetic energy of the system will be converted into rise in temperature. Here I'll write it. Delta K should be equal to 15 into specific heat rise in temperature plus 25 specific heat rise in temperature. Delta K is what? This delta K is what? Change in kinetic energy. 25 into 30 square plus 15 into 10 square by 2 minus of 25 plus 15 V square by 2. I think I should improve my handwriting also. Okay, fine. So, sir, what is this? We are not understanding. Okay, we'll do one thing. We'll take like this. This is the now we'll get the now you can see this is the ball A and this is the ball B which is moving. Ball A and ball B, they'll come and collide and they'll move with a common velocity. Now, due to this inelastic collision, there will be loss in kinetic energy. This loss in kinetic energy is utilized to rise the temperature of both the balls. So, for that, first we'll calculate the momentum. 25 into 30, 750. Something is happening. Troubling me, yeah. Now this one, 25 into 750. Okay, this will be 15 into 10, 150. Here, 15 plus 25 into V, 40V. We'll get the common velocity. Then we'll calculate the change in kinetic energy. This kinetic energy is utilized to rise the temperature. It's a problem based on calorimetry and collisions in 1D. In an electric field, this based on the question based on the EM waves. Let me read the question. In an electric field component, if E equal to 377 sine omega t plus kx omega of electromagnetic field wave, mu naught by f naught value given, find the average intensity of the wave. What is the expression for intensity of the wave? Where you have to bring this EM waves concept. What is the formula for intensity of the EM wave? You should be good in formulas, huh? Intensity of the EM wave. The topic is based on EM waves. Intensity of EM wave is given by half epsilon naught E naught square into C, or epsilon naught ERMS square C. Either of way you can remember the formula. And what is C is equal to 1 by root of mu naught epsilon naught. Now we can use this data. We'll get answer. Huh? Very simple. 18th one. A projectile is projected with speed v at an angle 60 degree with ground horizontal. Here. Projected like this, 60 degree. Find the ratio of difference of kinetic energies at point C and at point B. Very simple, huh? No need of any formal coaching. Huh? What is the velocity at highest point? U cos 60 degree. With the same speed, it will come and strike here, no? With what speed projected? With the same speed, it will come and strike. So what is the kinetic energy at B? Kinetic energy at B is equal to M U cos 60 degree whole square by 2. Kinetic energy is equal to mu square by 2 only. With what speed projected? With that one only. Find the ratio of difference of kinetic energy at point C and at point B with kinetic energy at point C. Kc minus Kb by Kc, which is equal to 1 minus Kb by Kc. Mu square by 2 will cancel out. So this will become mu square by 2, 1 by 4. 19th one. Two media of refractive indices N1 and N2 have a plane interface. In the first medium, speed of light is 2.4 and in the second medium, 2.8. Find the critical angle when the light travels from first medium to second medium. What do you mean by this here? We have the boundary here like this. The light is traveling from the first medium and the second medium, and this is the here V1. This will be mu1, mu2. This is the critical angle is asking. So this will become mu1 sin C equal to mu2 sin 90 degree. And V1, what we'll write? C by mu1, V2 as C by mu2. There's a critical angle. Critical angle, I'll write symbol like this. Mu2 will be C by V2 into 1. So sine of critical angle equal to V1 by V2. We'll get this much. 24 by 28. 6 by 7. Next one. A screw gauge has a least count of 0.1 millimeter. Using this screw gauge, a measurement was done. When nothing was present in the jaw, 0 of circular scale was above reference line by 3 units. When a spear was kept between the jaws, main scale reads 1 millimeter, 51 division of coincide with the reference, the actual diameter of the ball. Now this one problem came on the screw gauge. The screw gauge is having now 0 circular scale was above the reference line. I think negative 0 error. 0 correction will be positive. 0 error will be negative. 0 correction will be minus of 0 error minus of minus 3 will become 3. So the diameter, the actual diameter of the ball will be linear scale plus circular scale plus 0 correction into least count. Linear scale is how much? 1 millimeter. Circular scale 51 and this is 3. Least count 0.01 millimeter. 1 millimeter 54, 0.54 millimeter. 1.54 millimeter. I can't draw the diagram, just try to imagine. This is based on the experimental physics. If 0 lies above, it will be negative 0 error. This problem based on the semiconductor physics. Now we'll start like this. This is source, applied voltage. This is series resistance. This is Zener diode. This is a N-type. This is a P-type reverse bias, and this is a load resistance. Find the RS. Is asking to get the value of RS. What are the here current? IS will flow. IZ applying the plus minus. And IZ equal to 4IL. IZ equal to 4IL. 4 into 5 milliampere. 20 milliampere. Apply KVL in this loop. Plus 25 minus ISRS minus VZ equal to 0. But we don't know IS value, no? We don't know IS value. Applying the KCL. Here IS is equal to IZ plus IL. IS equal to here IZ plus IL. 20 milliampere, 5 milliampere, 25 milliampere. Now 25 minus ISRS minus VZ equals 0. 25 5 volt. This solving will get the answer. Zenodite is just all about applying the KCL. What all you should do? You should know how to use the KCL. Fine. Then next KVL. We'll take the next one. Find the relative error. A set of measurements of certain parameter is 20, 19.7, 18.25, 17.0. Find the relative error of set of measurements. What we should do for this? This I think based on the first we'll add up good maths, practice of maths for teacher also. You have to add up all the quantities. Then we have to calculate the average value. Let me write x average. This is x1, x2, x3, x4. Can you do calculation? I'll explain the concept. By 4. Then next in individual error will calculate x average minus x1. Delta x2 equal to x average minus x2. Delta x3 equal to x average minus x3. Find the relative error for the set of measurement. The relative error, then we'll calculate this one. All concept I'm explaining here. Relative error will be mean absolute error by mean value. What is the definition of it? Mean absolute error, this is a mean value. This is called as mean value. This is called as relative error. This is based on the figure beside represent stress versus strain versus stress graph, not stress versus reverse they are given. Which material has maximum Young's modulus? The one which is having least slope, theta. So how you define Young's modulus? Stress by strain. So therefore here strain by stress, which will become tan theta. Theta A, I'll write it like this. If you check it, theta A less than theta B less than theta C less than theta T. So therefore the Young's modulus A will be greater than that of B, greater than that of C, greater than that of D, based on elasticity. Now it's telling two immiscible liquids are filled in a vessel as shown. Find the ratio of velocity of efflux of hole A to that of hole B. Here liquid will come like this. From here the liquid will flow like this here. These velocity of efflux, this you write VA, PB. Velocity of efflux depends only on this H1, only on the depth. Is it okay? Now VA by VB equal to root of 2GH1 by 2GH2 will be root of H1 by H2. H1 is H by 4, H2 is 3H by H2 will be H plus 5H by 4. 1 by root 5. Okay, this based on the fluids, Bernoulli's theorem. Next, find the sum of acceleration of each blocks. The coefficient of friction between the blocks is 0.5. It is pulled by 50 Newton. Here, there's a friction is there. So now we are on 2 kg block. We applied a force, 50 Newton. 3 kg block is there, and the surface is smoother. So here, how the friction will act? Friction here will act in this direction. Friction on this block in this direction. Let's assume no slipping. Then F minus F equal to 2A, F equal to 3A, F equal to 5A, 50 equal to 5A. Acceleration 10 meter per second square. What is the limiting friction value? Mu into 2G. Mu is how much? 0.5, 2 into 10. 10 Newton. We'll calculate now. Frictional force 3 into A, 30 Newton, which is greater than limiting friction. So slipping occurs. Then what you have to do? Assume that slipping occurs. They will move with the different accelerations now. F minus FL equal to 2A1, FL equal to 3A2. 50 minus 10 equal to 2A1. 40, A1 is 20. 10 equal to 3A2. A2 equal to 10 by 3. Sum of these two is asking. 20 plus 10 by 3. 50 by 3. Approximately 16.6. We can put it approximately 70. A relative. Sorry, A1 plus A2. Sum. 17 meter per second square. Okay, fine. So this is based on the friction chapter. Okay, kids. These are the problems which they've asked. In fact, paper very easy. As usual, calculations you should be very stronger. Like how I'm struggling like this, you should not struggle. You will not get marks. Okay, all of you. We'll end up the class. So those who are writing tomorrow exam 24 and 28, please revise all the concepts and formulas. Happily go write exam. Definitely get very good marks very easily. Till then, all the best. Take care.